Hi everyone, welcome back to Maths Hub's YouTube channel. This is our ongoing series to help you conquer the world of the GMAT Focus Edition. In today's video, we'll be talking about decimals and their operations. Let's get started. Now, we previously spoke about fractions, right? So there are four ways in which you can represent parts of a whole, right? Parts of a whole. A lot of mathematical expressions are about helping you represent parts of a whole, right? So there are four ways to do that. One is fractions, second is a decimal, third is a percentage, and fourth is a ratio, one type of ratio. It's called a part to whole ratio, but most ratios are part to part ratios. Anyway, this video we're going to focus on decimals, right? So when you write a fraction as a part of a whole, you write something like a 1/4. So this is how we represent a fraction. If you perform a long division on this number, you know how that goes, right? So this is the dividend and this is the divisor, right? So you take 1 over here and put a 4 over here. So since 1 is less than 4, you take a 0 and then you put a decimal, and that gives you an option to take another 0 here, right? You can take an imaginary 0 out here, and then you say 4 2s is 8, and then that's a 2, and then another 0 comes up, and 4 5s is 20, correct? So that's 20. So then you get a 0. So this means 4 into 0.5 gives you a 1. You can represent this fraction as 0.25, right? So you can represent the fraction as the quotient of the division of 1/4, which is 0.25. That is the decimal representation, and this dot is what we call the decimal. And that's why this number is called a decimal representation. You can also convert this to a percentage and a ratio, which all of them are representing the same sort of a concept of a part of a whole, but let's not deal with that in this video. We'll do that in upcoming videos, right? Now let's go deep into understanding more about decimals. Great. So the first thing is we always need to understand that a decimal and a fraction are always interconvertible, right? So a decimal and a fraction are always interconvertible. They are basically the same thing, right? So you can always write this decimal as that any decimal can be written as that particular number divided by as many zeros after 1 as that many decimals, right? So for example, this particular number has 25. So you write 25 on the numerator and you divide that by as many zeros. So you put a 1 and as many zeros as there are decimals, right? So there are, after a decimal point, there are two numbers here, 1 and 2 after a decimal point. So that's 2 zeros. So any decimal can be written in this fashion, correct? So if you have, let's say, a 0.583, you will write it as, so you first check, put this number over in the numerator. So you write it as 583, right? So you write this entire thing on the numerator and you divide that by, first you put a 1 and then you write how many numbers are there after the decimal place, right? So after this, how many ever numbers? So that's 1, 2, 3. So any decimal can be written as a fraction in this term. After this, you can further simplify it. You can write it as 25 ones is 25, 24 is 100, which is 1/4. That's okay. So it's a simplification of this same term, but you can always write it in this fashion. And this can get a little bit more tricky if you have a more complex number. Let's say, for example, you have a number like 0.0086, right? So don't worry about these zeros. So you just write the entire thing on top anyway, right? So you write 0086 and you divide that by number of zeros, right? So you divide that by number of decimal places after the decimal, right? So 1 2 3 4. So that's right. So it's 1 2 3 4. You can also write this as 86 because zeros before the actual number don't matter, right? So 86 by 1 2 3 4. Zeros only matter after the decimal. They don't matter when there's no decimal. Now the decimal is over here, correct? Because we put the rest of them below. Now this is how you convert any decimal to a fraction. So once that is out, we can talk about more important things. Great. So as you might know, we can also convert the same representation into an exponential format, right? So let's take the same example for the sake of simplicity. Let's say 0.25. So you convert a 0.25 as we just saw. We just write this as a numerator, and then you put in the denominator you put a 1 and followed by how many zeros are there in the denominator, right? So it's 2 zeros. Now you can write this exact same thing in another format, right? So you know that whenever you have a number in the denominator, that's equivalent to having exponent to the power of -1, right? So anything which is written as 1/a can be also written as a to the power of -1. This is how you can convert an exponent to a fraction and a fraction to an exponent. So a fraction, any number in the denominator can be written as a number to the power of -1. So now this can be written as 25 into 100 power minus 1. Or you can also write it as 25 times 100 is 10 square, right? So 10 to the power of minus 2. So this means that you can write any decimal as that number multiplied by 10 to the power of negative number of decimals, number of numerals after the decimal point. So there are 1 and 2. So that's why you have a power of minus 2. Let's take one more example to make it clear. So let's say we have 0.883. So you're going to write first these three numbers separately. Forget about the decimal, just focus on these three numbers. So that's 883. Multiply that by 10 to the power of minus. So whatever comes in this will be the number of numerals after the decimal point. No matter what there, it could also be a 0. Everything should be counted for, right? So after decimal, whatever number, that's 3. So convert now a decimal into an exponent. So you're converting a decimal into an exponent, right? So you're converting a decimal into an exponent here. So previously we saw converting decimal to a fraction, and you convert decimal to an exponent. So now if we take another example and do all three together. So let's say you have a number like 0.00728. So you can convert that to a fraction by writing all these numbers on top. And anyway, you can ignore the zeros once you are able to do it faster, right? So you can write 728 divided by, don't forget about adding zeros in the denominator, no? So you need to have 5 zeros. So that's 1, 2, 3, 4, 5. And you convert that to an exponent. You will write, you can either write it from here or from here. So you can write it as 728 multiplied by 10 to the power of minus number of zeros, right? That's 5. So that's how you convert a decimal to a fraction or into an exponent. And this exponential form is useful in the lot of operations, especially in form of while adding decimals, while subtracting or even addition and multiplication. Because this format is slightly more tricky, this is very easy to work with. Let's see how that works. Great, so before we move into understanding the different operations of decimals like addition, subtraction, multiplication, let's recall that there are mainly two types of decimals, right? So there is one type of decimal like 1/5, which becomes a 0.2, or even the one which we saw like 1/4, which becomes a 0.25. So these decimals end at a particular point, right? So after this point, there's just a 0. You can add as many zeros as you want, it doesn't really matter, right? So they basically end over here. You don't need to worry about everything else after this, right? So they just end over here. They basically have a hard stopping point. It's exactly 0.2. It's exactly 0.25. These kind of decimals end exactly at this point. This number is exactly equal to 0. This number is exactly equal to 0.25. And there are another kind of decimal. Like for example, if you take a 1/3, this would be equal to 0. So if you divide this, right? So what happens? If you divide a 1 with a 3, you get, so you put a 0 and you put a decimal, which allows you to put a 0 over here. And then you say 3 times 3 is 9. So 3 times 3 is 9. You get a 1 again. So since you have a decimal, you put a 0 again. So again you say 3. Again you say 9. That's a 1. Again, you can see that it's never going to stop. You will keep getting a 9, keep getting a 1, keep getting a 9, keep getting a 1. So it's a never ending process. It goes on up to infinity. So this is an infinitely moving number, right? So this is never going to stop. This number has no exact value. It is going to be 0.33333. Even if you wait till the end of the universe, you will not be able to stop counting the 3. So that's a very interesting idea in mathematics. In math, this is called a non-terminating. It means it doesn't end, or a non-ending for simplicity's sake. So this is equal to 0.33338. It's also written as 0.3 bar. So if you say a bar on top of a decimal, it means that this is not ending. This is going to continue on forever, right? Similarly, if you take something like a 1/7, this is a little more interesting because this doesn't end with one single number. Rather, it's a lot of numbers. So it is equal to 0.142857. So I just remember this. Don't worry about remembering this. I just happen to be a nerd and I remember it. So this interesting thing about this number is this entire thing recurs, which means this number is going to be, after 7 you're going to have a 1 again, and a 4 again, and a 2 again, and a 5 again, and an 8 again, and a 7 again. So this 142857 part keeps repeating to infinity. It's not the same number like 33333. Other 6 digits would keep recurring one after the other. So in this case, we say the recurring is 0.142857. The entire thing recurs. So these are, as we saw, these are called non-terminating decimals. Okay, because they are literally not terminating, they are not going to end, or you can easily remember it as non-ending decimals or endless decimals or whatever you want to call it, because the name doesn't matter to anybody apart from your 7th standard school teacher probably. So it's basically a decimal which doesn't end, it just keeps going. And these are called, these are non-terminating, and these are obviously called terminating or ending or stopping or whatever you want to call it, you can call it. Just need to understand the idea behind it. The idea is this stops over here. This is exactly 0.25. This is not exact to anything. This is just going to be going on for infinity. So we don't know exactly how much that is. We just say that it is 1/3 or 1/7 or 0.3 bar or 0.142857 bar, right? That's a very crucial and I find it a really interesting idea. Now let's go to the actual operations bit. So the first is addition, right? So let's look at addition. Pretty simple, pretty straightforward. It's just, let's say you have two numbers like 0.358 and 0.026, right? So first thing you need to look at is the decimal point. So decimal points first need to be aligned with each other. That means they need to be falling in the same order, same alignment, right? So it has to be one below the other. That means when you write this number, you write 0.358 and then you write this decimal exactly below this. So actually, for a little confusion, let's take a number like 0.02 instead of 0.026. So you cannot write this as 0.02. You can't do that, right? So this is not going to work. You won't be able to add this together. So instead, you always focus on the decimal, right? So you focus on this part. So this has to align with this bit. So this means you put a 0 over here and a 2 over here and a 0 over here. Now you can add these. So always remember, the most important thing is to align the decimal points. Now, when you do that, you get an 8 and then you just add normally, right? So 5 plus 2 is 7, 3 plus 0 3, and then you put a dot and then 0. And that's how you get this done. Amazing. Similarly, subtraction is exactly the same. You just need to align the decimal points. You just align the decimal points. So let's subtract the same two numbers. 0.358 minus this. So you got to put a dot here and then 0 and then 2 and then 0 and then subtract this now. So the same way you subtract normal numbers, so you put an 8 over here, 8 goes here, this is 0, 5 minus 2 is 3, 3 minus 0 is 3, 0.338. So that's the subtraction. This is addition. So only thing you need to remember here is, of course, you just need to align the decimal points together, that's it. And how many ever decimals you have, you just need to put it one below the other and you can subtract them or add them. Great, so now let's move to multiplication, which is a little bit more tricky. Okay, how do you multiply decimals? So the biggest trick is, for let's say you take two numbers 0.825, want to multiply that with 0.35, let's say. Now the biggest trick is to just look at the numbers first and forget about the decimal points. So you multiply 825 with 35 and then worry about the decimals later. So you first multiply these two. So you have 825 and 35. So 25, 12, 40, 41, right? 5 5 is 25, 5 to 12, 5 8 is 42 and 41, right? So 3 5 is 15. So when you multiply this, you're gonna add a 0 here, right? Because it's 30. So 3 5 is 15, 3 to 6 is 7, 3 8 is 24, right? So that's 5, 7, 8, 8, 2. So you don't need to be a magician while calculating numbers. It's not going to be a big problem in any exam as such. Even if the most important thing is that you're accurate and not too fast. Even if you take a little bit of time in calculations, it's fine. You will still be able to crack exams. And the next step, so first you took a look at the actual numbers, and the next step is to count the decimal points. So there are 1, 2, 3, 4, 5 decimals overall, right? So when you multiply, you get to add the number of decimal points. When we'll understand why that is, let's see why that happens. And then you will add that many decimals to this number. So that's starting here 1, 2, 3, 4, 5. That's going to be 0.28875. That is the multiplication. Now, as we spoke before, we can write this as 0.825 times 10 to the power of 123, right? 10 power minus 3. And you can write this as 35 times 10 to the power of minus 2, right? Now we can multiply these two, and when we can multiply these two, correct? So this is going to be the same number. So that's 28875. And as we learned in exponents, we know that if you multiply two exponents, you get to, if the bases are the same, so you have the same base here, right? Say both, this is also 10, this is also 10. When you have the same base, you can add the exponents, right? Which we also spoke about recently. That is 10 power minus 3 plus 2, which is 5, 10 power minus 5. So as you know, this is also another way to represent the same thing, correct? And you can convert that to decimal if you want. So you can say, you will put 5 places to the left, right? So 0.28875. So using an exponential form sometimes is really useful and helpful because you may not need to multiply sometimes. You just need to probably get it exponent in some questions. And it's actually even more important, even more easy to divide. It's exactly the same thing, right? So you will just, for division, you do exactly the same thing, correct? So let's say you have 0.555 and want to divide that by 0.11. So you're gonna, either you can write it this way, 0.555 by 0.11, and you can first convert that to an exponent. So that's 555 times 10 to the power of 123, right? 10 power minus 3, and divide that by 11 times 10 to the power minus 2. So that's why converting it to an exponent is so handy. You can easily work with this without forgetting, without thinking about the decimal point, right? So you take 11, 555, 0, and then 0.4445. And that's going to be a recurring decimal. So you convert that to, or let's take 0.555. That'd be easier for us. So if you do that, then you will be able to get a better answer with 11, right? It's going to be 10 power minus 4. It's going to be 5555. So 11, 555, 0, and 0. So 505. And this, as we know, when you have two exponents, you can divide the numbers, right? So you can, when you have two exponents and division with the same base, you can subtract the powers. So you can subtract the exponents. So that's 505 times 10 to the power of 4 minus 4 plus 2, because minus 2 becomes a plus 2 when you subtract from minus 4, no? So it's minus 4 plus 2, it's minus 2. That's 505 times 10 to the power of minus 2. So it's going to be 5.05. That is your division. So the interesting thing here, most importantly, you need to be able to convert a decimal to an exponent for you to make things simple. You can easily convert to a decimal, and then you can, without a hassle of the decimal point, you can just multiply or divide normally and then just divide the exponents or multiply the exponents. That's it. Right? Okay, now let's move to the next thing. Now that you understood the basic or recalled the basic operations, there are some decimals which you need to remember for the sake of being able to move fast while you're in the exam, right? So remember basic. So these are some of the basic decimals or fractions that you can keep in mind, right? So for example, all the tenths, right? So tenths, there's tenths, there's fifths, there's thirds, and there's fourths, and there's fourths, right? So remembering these is going to make your life much easier. So let's say you have a 1 by 10, you have a 2 by 10, you have a 3 by 10, you have a 4 by 10, 5 by 10, 6 by 10, and so on. 7 by 10, 8 by 10, 9 by 10, 10 by 10. So remembering all these is very simple, right? So you convert this to a decimal, is 0.1, this is 0.2, this is 0.3, this is 0.4, 0.5. This is very useful. You have to remember these. You have to know these by heart, basically. It should be something which is at the back of your hand, right? 0.7. Now what about fifths? So 1 over 5 is 0.2. You have to know that instantaneously. It's like knowing 2 plus 2 is 4. So 1 over 5. 2 over 5 is 0.4. 0.4, right? 0.4. Three over 5 is 0.6. And finally, 4 over 5 is 0.8. You need to know these. And next you have thirds, right? So you have 1/3, you have 2/3, which would be 0.3 bar, or you can simply say 0.33 for the sake of simplicity of calculations in GMAT. So you can write, it's actually 0.3 bar, which is an infinite decimal, but you can approximate it to 0.33. Don't approximate it to 0.3 because 0.3 is exactly 3/10. So let's not do that. But you can approximate it to 0.33, which is going to work out for you in GMAT. Now, as I said earlier, I was talking about not being able to calculate very fast is okay for the GMAT. I was talking about huge calculations. Like, for example, if you get a calculation like 28892 multiplying by 45, it's okay. You can take your time to calculate that. That's fine. But simple things like you cannot take time to calculate 4 into 5. That's not going to work. You can take time to calculate the bigger ones, and that's going to be a tougher problem from a calculation standpoint. And you might even want to skip that question, right? If you don't have enough time there. So now 2/3 is approximately equal to 0.66. Is exactly equal to 0.6 bar. Or you can say it's 0.67. That's a more accurate representation. So you will say it's approximately equal to 0.67. So you need to know that as well. And then next you have fourths, right? So that's 1/4. So 1/4 would be 0.25, right? Exactly. Okay, let me write that in red. So 1/5 would be 0.25. So and then 2/4, 3/4. So you're gonna have 2/4 is exactly half, exactly the same as 5/10 or 1/2. So 2/4 is 0.5 and 3/4 is 0.75. It's exactly equal to 0.75. Now moving ahead, you have something called eighths. Have eighths. So in eighths, you will have 1/8, 3/8, 5/8, and 7/8, which you need to know. So 1/8 is 0.125, 3/8 is 0.325, 5/8 is 0.625, 7/8, this is 0.875. So 7/8 is 0.875.